Okay, guys, so we were previously looking at some theorems in relation to the circles. And so what I want to do now is to have you just try this exercise just to see how much you would be able to apply the theorems that you already learned. All right, so I'm just going to give you about 2 minutes, don't need so much, to answer these questions here. So when you're finished, raise your hand, and then now we can go through them together. And then now after this, we can look at some more questions. All right, guys, so take the 2 minutes now, try to answer these questions here. Anybody finished with the question, guys? It shouldn't be taking you that long. What is the answer to section A or to question A? The screen, what's the answer to A?
30, sir.
Okay, what is the reason for that?
Sir, angle of C and distance are equal.
Say that again, miss.
Sir, angles of same distance
Angles
are
of
equal.
same distance? No, that's not the reason. Can you give the reason, Miss Waysome?
Sir, 30.
Yes, so the answer is correct. It is 30, but I was asking for the reason. Why is it that it is 30?
Sir, my theory came from Snowset 30.
We don't want you to use your theorem this way, so I want you to use a theorem you learn. What theorem you learn?
So remember theorem.
It is saying that angles formed within the same segment or on the same arc, separated by a chord. So this is the angle and it is in the same segment. These two angles are in the same segment. And this is a chord that was used to separate them. So this segment up here, they're all formed on the same circumference in this segment. So that's why they are the same. Right, Ms. Waysam?
Yes, sir.
All right, what about question B, Dorothy? What's the answer?
60, sir.
You sure it's 60, Ms. Waysam? I mean, Ms. Dorothy, sorry about that, Ms. Waysam. You sure it's 60?
Sir, because the other angle is 120.
All right, Miss Green, what's the angle for B?
120, sir.
120. What's the reason why B is 120, Miss Green?
Sir, something about angles on a segment are equal.
Angles formed in the same segment on the circumference are equal. Ms. Darty, you see why these are equal?
Yes, sir.
Explain to me why they are equal, Ms. Darty.
Sir, you just said that angles formed in the same segment of a circle are equal.
What does that mean to you? Explain.
That the both angles and the segment, they both measure the same measurement.
Where in the segment do the angles form?
And at the circumference.
Right. So angles within the same segment form at the circumference are equal. All right. All right, Ms. Darty. What is the angle for question C? What is the angle at C?
$70, sir.
What is the angle at C? Miss Waysome, what is the angle at C?
35, sir.
Ms. Green, what is the angle at C?
Sir, I'm agreeing with some with 35.
Okay. And why would that angle be 35?
Sir, because the angle at the center would have been 2 times the angle that form at the circumference.
All right.
So just divide that by 2 where you get 35.
Okay. You understand that, Ms. Sarty? So you see that this angle form at the center here is 70.
Yes, sir.
Times the angle at C. So it means that you would have to find half of 70, which is 35. You see that, Miss Darty?
Yes, sir, I'm seeing it.
All right, Miss Darty, what is the angle at D?
So that will be 35.
You're asking me, are you telling me?
Hmm?
Are you, Miss Darty? Miss Darty?
No, I'm saying, sir, if it's gonna be 30, it will be 35.
So I'm asking if you're asking me, are you telling me?
No, I'm telling you, sir.
And what is the reason?
Because sir, the angle at the line, angle at the center, the angle at the center is 2 times the angle at the circumference.
Within that segment or sectoral.
Yes, sir.
All right. All right, Ms. Darty, for question D, what is the angle at the center, which is E? What is angle E for question D? What is this angle?
Sir, that would be a 146.
Why is it 146?
So because the angle, the angle at the center is 2 times the angle at the circumference or the segment.
Okay, anybody else agree with Ms. Darty for this one? Raise your hand if you are in agreement with Ms. Darty. Okay. All right. Okay, good guys. Good job. All right, so we're still going to be looking at some more questions in terms of the circle theorem. All right, so here we have 4 more questions here. And you're basically doing the same thing. You're finding the angles labeled, the unknown angles within the circles. All right, so go ahead and do a calculation for these. And then now we can go through them. So I'm going to give you about 3 minutes to attempt these guys. Anybody finished with these questions? All right, let us start off with the question E. Miss Dorothy, what is the angle at F?
Sir, 35.
How you arrive at 35, Miss Dorothy?
So at angle O is 2 times the angle at the circumference at the segment. So as this is like 35 is in the at the angle.
You said angle O is 2 times the one at the circumference, which is 2 times angle F. But what is angle O?
We don't know what is angle O, but we know that it is 2 times so the angle at the circumference.
All right. Miss Green, what is the angle at F?
F, so I'm guessing 35.
The angle at F is 35.
Yes, sir.
Okay. What is the reason for the angle at F to be 35?
Sir, I don't have a reason, I was just guessing.
Okay. If you're just guessing, you may possibly guess the wrong answer. You have to know the theorems and apply them. Remember, we had just now looked at the theorem for semicircle. What did that theorem says? What did the theorem says about angle formed at the circumference within a semicircle? What's the size of that angle? You forget already, guys? Don't remember it says? Don't remember what it says? Nobody remember what the theorem says?
Sorry.
Go ahead, Miss Dorothy.
So the angle produced at the circumference is a right angle.
Why is it? Why is it that? Give me a reason, Mr. Martin.
So because the angle on a straight line measuring 180.
And what that has to do with this angle here?
And if angle on a straight line measuring 180 is the angle only be 2 times what is in the circumference of the segment.
So angle O will be twice this angle at the circumference. Correct. And remember that the theorem for semicircle says that any angle formed within the circumference of a semicircle is 90 degrees. You remember that, Miss Green? Miss Green?
Could you repeat, sir?
You remember what the theorem on semicircle says? It says that any angle forms at the circumference of a semicircle. Remember, a semicircle is a half circle. So any angle forms from the half circle to the circumference is 90 degrees. And if you have a full circle, you can apply the same rule as angle form at the center is twice what form at the circumference. Is that clear, guys? Raise your hand if you're understanding so far. Miss Green, are you following?
Yes, sir.
Okay, so you understand why angle F would be 90. All right, so this would be 90 degrees. Now we have one more angle within that triangle here to calculate. What is that angle? What is the angle at G, guys? What is this angle?
Sir, 65.
Why 65, Mr.
Sir, if angle O is a straight line and it's measure 180, and you have angle F is 90, the other angle is 35. When you add that, you would get 125. So angle G would be 65.
You sure about that?
Sir, because 165, when you add the 65 to the 125, that will give you 180.
Say that again, miss. You say angle G would be 65.
Yes, sir, because what I did I add the 90 with the one with the 35,
Mm-hmm.
and I get 125. So
Mm-hmm.
I'm saying angle G would be 65 because when you add both, all of them together, you'll get 180.
So you add 90 with 65 plus 35, and you get how much?
180.
65 plus 35 will be how much?
That
65
I
plus,
did by 100, sir.
huh?
That would be 100.
And if you add that to 90, what you get?
190.
So it cannot be 65, Mr. Harvey.
So that would be 155 then, sir.
What is the angle at G?
55.
55 plus 35 would give you how much? Mr. Harvey?
60. That would be 90, sir.
That would be 90. And 90 plus 90 will give you
180.
180. All right. You're back now, Miss Wilson?
Yes, sir.
Yeah. I just saw your message a while ago. All right. Did you get an opportunity to do question one, Miss Wilson? Miss Wilson, did
Sir, I can try now if you want me.
not if I want you to. We're doing the question. Yes, Miss Wilson. Mr. Isam?
Sir, are you hearing me?
Yeah, I'm hearing you now.
Yeah, you were saying?
I was saying to you that we are going to the questions now, so I'm not sure if you try now would really make a difference. You can try it for the sake of,
Yes, sir.
yeah. But we are moving on to F. So what I'm going to do, did you get the answer to F, Miss Green and Miss Darty?
Yes,
Yes,
That's
sir.
good answer.
Oh, you got the answer to that one. All right.
No, sir, I did not get an answer for F.
You don't get the answer for F yet. All right. What I'm going to ask you all to do is to do question F now. I'm giving you about 2 minutes to do F, and then I'll work it through with you. I'm going to start in the meantime. You can try work the two questions E and F. All right.
Okay, sir.
Ms. Raysam,
yes, sir.
try doing E and F too as well.
Okay, sir. E and F.
Yeah, question E, question F.
Okay, sir.
Fill in the value for the unknown letters.
Yes, sir.
Did anybody finish? question F. Anybody finish F?
Sorry, I'm finished.
What you get for X, Mr. Artie?
Sir, 47.
You get X to be 47. Why is X 47?
Sir, it for the theory it said that the same segment of the circle are equal.
No, but this angle that forms here is not it is not being formed at the circumference from X. It has to be formed from X to the circumference. So if you were forming to the circumference, you would have to have it the two angles that are here, they are not really of the same. They are not on the same circumference, so to speak. Because you'd have to form the angle from this point and this point at the point on the circumference. So if you draw this, come all the way over here, this line have to come back down here for it to be formed on the circumference. And if you draw this line come here, then that wouldn't form an angle. So this angle is not on the circumference based on this line. What else do you know? Miss Green, what is the angle at X? Are you with me, Miss Green? Are you there?
Yes, sir, but I don't know the answer.
Miss Wilson, what is the angle at X?
Sir, I'm honestly not sure.
Okay. All right, let us go back to E. What is the angle at F here?
I got 90.
So if this is 90, what would be the angle at G?
35.
The angle at G is not 35. Remember, this is a right angle triangle.
Which one, sir?
This triangle here is a right angle triangle.
Sir, it never look like it to me. I think that it isosceles.
No, it is not what it looks like, Ms. Wilson. You're going according to the theorem. Don't follow what it looks like. Remember,
Okay.
the theorem says any angle formed within a semicircle
Yes, would be.
a right angle here on the circumference.
Okay, sir.
So if you have a triangle where one of the angles is a right angle,
Mm-hmm.
a right angle triangle. So if this is 90, this is 90, and this is 35, what G going to be?
Sir, that would be 125 from 180, which would be
55.
50, yeah, 55, sir.
Right, so this would be 55.
No, sir. You look on it as an isosceles.
No, don't look at it as an isosceles. If we were talking about isosceles, we would need the circle theorem.
Okay, sir.
Right. Now, go back over to this question now. Look at the angle X. Look at this angle here. What is this angle up here in this corner here?
That would be a right angle triangle right there.
Exactly, it would be a right angle triangle. What would be this angle here?
So we know that is 90 already.
What is this angle here?
Come in, sir. 137 from 180.
It is not so difficult to calculate. X plus 47 will be 90. You take away 47 from 90, you get X.
Go again, sir.
Subtract 47 from 90 and you get the value of X.
True.
Yes.
I'm confused then.
That get 43.
Remember, this is already 90. And it be
Yes, sir.
90.
So what I was doing, I was adding 47.